Hello, my name is Michael Halpern, and I'm going to be giving you a little walkthrough of my final project for my passage this semester, which is building a machine learning model, unsupervised machine learning model called a genetic algorithm to determine the best schedule to fit student needs, as well as the classes teachers are teaching at a hypothetical school. So I'll walk you through line by line, and hopefully you'll learn a little bit about my project as well as how genetic algorithms work. So the first thing I do in this project is I import all these different libraries. These add extra functionality to Python, anything from allowing me to track time to add different functions, so I don't have to write as much code, basically a bunch of conveniences. The next thing I do down here is I just start a timer. We'll see this later. This is just to track how long my code runs for, and give me some data on if I can improve efficiency of the code, kind of what I'm going through and debugging later on. So the first thing we do here for data entry is I'm going to add all the different teachers and the classes they're teaching. As you can see, for example, Bob is teaching a middle school literature class, a speech class, another middle school literature class, one conference period, and then two literature classes, which are for high schoolers. So I've done all that, and then I've added every teacher into a list. So this is basically a list of lists. So within this list of teachers, if I want to access Bob, Bob then will reference, let's see, Bob up here. And so this list within a list just allows me to kind of store data in a more compact way. And we'll do a similar thing with all the different grade levels here. It's just a quick example of what it can look like. So for example, 7th grader may be taking Math 7, a science class, a literature class, social studies, a PE class, and a Spanish 1. And then once again, I'm going to make a list of the lists, or basically a list of all the students, which I'm going to use later. Cool. And then the student weights down here, it is kind of a fun side thing I added. So what this allows is if we want to add more preference, let's say we want to make sure 12th graders are really represented and get the classes they want, we can simply change this weight, let's say 10. And so that means that 12th graders would be 10 times as important as any other grade level when evaluating if a schedule is fit for the school. Cool, so moving on here, we have this first function here, which is create permutations. So what this does is for every different student over here, so let's say I take 12th graders for example, it takes every single possible option or order that this list can take place in. So we say what if pre-calc could be first, so we have this obviously is the first one, and let's say we just switch two classes, so speech goes here and art goes here. So if we just switch two classes, that'd be another schedule. And so what this function does is it creates all the possible schedules for each grade, which we're going to use later on to test the fitness of the schedule for the teachers that we're going to create. So here I'm going to go and create an initial population. So this is just my first population, and what it does is it scrambles all the different teachers. So if we scroll up again, basically each of these is going to be randomly changed. So I'm going to get a random list in order of Jason classes, random order of Marla classes, etc., etc. Cool. And so next thing I do is I'm going to evaluate how good each of these schedules is. And so I run through here and I compare each of these schedules to each of the possible student schedules, and I say, okay, does this schedule where Marla teaches Math 7 first hour, Jason teaches Geometry second hour, does it work with this student? And so what will happen here is eventually I get an answer, and we get the total fitness of that schedule. So let's say a schedule works with 15 student classes, then that schedule would be scored a 15. If it works with 20 student classes, it would be scored a 20. And so this is basically evaluating each schedule and figuring out how useful it is. The next thing I have here is a crossover function. And so in a genetic algorithm, one of the principles we're using is we're taking the highest scoring schedules, so the schedules that fit the most student needs, and we're going to basically make them cross over or have offspring. And so what happens is we take these schedules and we randomly choose elements from each schedule and we put them together, and hopefully we're going to end up with a better schedule. So that's basically what this function is doing. We're going through each of the parents and we're creating an offspring, which is hopefully has the best qualities of each of the parents. So you can kind of see that there. The next function I have here is what we call a Hall of Fame function in genetic algorithms. And so Hall of Fame functions basically takes the top performing parent in the last generation, and it says, okay, we're going to basically make an exact replica. So the top performing parent automatically becomes an offspring with no changes. And so let's just make sure that we're not having any deteriorations in the quality of offspring, and the current generation is at least as good as the past generation. The next thing I have here is what's called mutation. And so this is a really important function in genetic algorithms, and much like biology, if there's no random changes in species or any mutations that happen, it can come to kind of a standstill. So there's just offers kind of the opportunity for a random mutation, and maybe just by chance it will have a positive effect in the outcome of the schedule. And so we do that for all of the schedules after we cross them over with offsprings. And then this is another evaluation of fitness, very similar to how we evaluated the fitness before. And then this is all those functions combined. So what happens is all those functions we used above are going to be added into this one big function. So this is basically a function of a bunch of functions. And so this allows us to kind of run through each of it. So you'll see here that we start off by creating permutations, then we'll create an initial population, and then we'll figure out the fitness of all the offspring, and then we're going to keep the best offspring in the Hall of Fame function. We're then going to reproduce with all the offsprings and hopefully make babies that are better. We're going to have random mutations in those babies, and then we're going to print basically the best score. And so I'll showcase that real quick here. Just scroll on the bottom here. I'm going to hit run right up here, and hopefully we'll get a good result. Let's see. Of course, it's running through the genetic algorithm and doing all the computing it needs to do. Let's see what we get here as a result. If any, it might take a second. Perfect. And so right here I have a graph of kind of the progress. Unfortunately, in this one, fortunately we did it in one generation. So kind of the first initial population had an offspring that was perfect and fit everybody's needs. And you can see it took 4.23 seconds, and it only took one generation. And right here is a graph of the generations, but we only have one data point, so there is no graph. So I'm going to run it again and see if we can hopefully get a worse result. In the fact that it will take more than one generation, but hopefully be more educational. Let's see here. Just giving it a second to run. Let's see, it's taking a while, so maybe there's some hope. Perfect. So we got 10 generations. And so I've limited at 10 generations, so this also has an interesting result. So it took about 16.7 seconds, went through 10 generations, and I think the maximum score is a 36, and we only received a 35 here. And so that's kind of interesting. But let's see if we can kind of make some changes real quick here. If we decrease our initial population, like let's say an initial population of maybe 3, we can get a result that hopefully doesn't produce as many good schedules, and we can see some sort of graph or change over time here. Perfect. We'll give it just a second here to run. Oh, one generation again. Well, I think you kind of get the point. What's happening is we're just running through generations, figuring out kind of what the best schedule is, and of course, we just go up to the top here. You can see that I've kind of given it some easy parameters, so it's not taking too much to get through it. Of course, we only have, I think, 6 different students potentially here, and if we add more, the schedule would take longer, and eventually, hopefully, come to some sort of conclusion on what the best schedule is, or even what a good solution is. We're not necessarily looking for the best solution, but we're looking for a solution that is acceptable. No problem. Cool. Okay. Well, thank you for following along with my quick tutorial and kind of explanation of my final project for my machine learning passage. I hope you enjoy the rest of the presentations and enjoy the rest of your night. Thank you. Bye-bye.